OpenAI, Google, Meta, Anthropic. XAI, 5 companies spending hundreds of billions of dollars trying to beat each other. Every few months another model, another benchmark, another declaration of victory. It looks like the most expensive technology race in history. So why are they all buying from the same company? That's like Coke and Pepsi fighting for market share, while buying every bottle from the same factory. It shouldn't make sense. But that's exactly what's happening. Ignore what these companies say. Look at what they actually bought. OpenAI signed up for computing systems measured not in servers, but in gigawatts. Anthropic committed tens of billions of dollars to computing capacity. Meta stockpiled hundreds of thousands of AI processors, then came back for millions more. XAI built one of the largest AI computing facilities on Earth in just a few months. Different companies, different strategies, different victory speeches, the same supplier. Buried inside every one of those announcements is the same name. Not another AI lab, not a cloud company, a chip company, one that spent most of its history making hardware for video games, and is now the most valuable company in the world. So maybe we've been looking at the AI race the wrong way. Maybe the story isn't about who's building the smartest AI. Maybe it's about who everyone depends on. To understand why, you have to let go of a comforting idea. That AI progress comes from genius, from some breakthrough insight scribbled on a whiteboard for decades. That's how it worked. Then, around 2020, researchers noticed something that changed everything. If you took the same basic recipe and just made it bigger, more data, more parameters, and above all, more computing power, the model got smarter. Reliably, predictably, almost like a law of physics. They literally called them scaling laws. Think about what that means. If intelligence improves predictably with compute, then intelligence is no longer really an invention. It's a product, something you manufacture. And like anything manufactured, it has a raw material, not code, not even data. Compute. Raw industrial quantities of mathematical processing. That discovery quietly transformed the AI race into something much older and much more brutal. An industrial arms race. The lab with twice the compute doesn't just move faster. It can build things its rivals simply cannot build at any price. Which is why the money you're watching pour into AI, the hundreds of billions, isn't mostly going to researchers. It's going to hardware. So the next question writes itself. If compute is the raw material of intelligence, what machine produces it? Here's the strangest part of this entire story. The machine that manufactures intelligence was designed to draw video games. A normal computer processor is like one brilliant worker. It does one thing at a time, incredibly fast. But drawing a video game means calculating millions of pixels at once, and for that, NVIDIA built something different. A chip with thousands of small workers, all calculating in parallel. A GPU. For years, that was the whole business. Explosions, shadows, reflections. Then, in 2012, 3 researchers in Toronto entered an image recognition competition with a neural network trained not on a supercomputer, but on 2 consumer NVIDIA gaming cards, hardware a teenager might buy. And they didn't just win, they crushed the field so badly it ended an entire era of computer science. Because it turns out a neural network is, mathematically, mostly one thing. Enormous grids of numbers being multiplied together, millions of tiny calculations all at once, which is almost exactly a video game explosion. NVIDIA had spent 20 years accidentally perfecting the machine that makes intelligence. Artificial intelligence stopped being discovered. It started being manufactured. And the moment that became obvious, every company in the race reached the same conclusion at the same time. Buy the machine, whatever it costs. These are the richest buyers in the history of buying. Money was never going to be the problem. Which is exactly what makes the next part so strange. Because when the wealthiest companies on Earth showed up with open checkbooks, they discovered a wall that money cannot move. Here's what almost nobody outside this industry understands. You cannot simply buy these chips. There is a line. And to see why, we have to do something almost no one ever does. Zoom into the neck of the hourglass. From the outside, a company worth trillions of dollars. Zoom in, its product, an AI processor. Zoom again. That processor is not one chip. It's a sandwich, a processor die fused to towers of ultra-fast memory, stacked layer on layer, bonded together with a packaging technology so precise that only a handful of facilities on Earth can do it. Zoom once more, and the almost comical truth appears. Nearly all of it converges on one company, TSMC. And its advanced packaging lines, mostly on the island of Taiwan. That capacity has been effectively sold out for years into the future. The memory that goes into each chip, also sold out. And you can't fix this with money because everyone in the line already has effectively unlimited money. Building new capacity takes years and tens of billions of dollars. The supply is fixed, no matter how much cash pours into the top of the glass. Stop and look at what we just found. The entire AI industry, every model, every lab, every trillion of market value narrows down to allocation slots in a handful of buildings. The bottleneck has a bottleneck. And when supply is fixed and demand is infinite, price stops being what matters. Allocation is what matters. Who gets how many chips and when? And the company that decides allocation is NVIDIA. It isn't just selling to the racers, it's standing at the neck, deciding how fast each of them gets to run. But wait, something about this shouldn't work. When a store sells out, customers go to another store. AMD makes AI chips, Intel makes AI chips. So why doesn't the line simply move to a different door? Because the chip was never the whole machine. In 2006, NVIDIA did something Wall Street hated. It spent billions building a software layer called CUDA, a way for anyone, not just game developers, to program its graphics chips. For nearly a decade, it looked like an expensive hobby. Scientists used it to simulate proteins and model weather. It made almost no money. But something invisible was happening. An entire generation of researchers was learning to speak it. When the AI explosion hit, every framework, every library, every tutorial, every grad student's half-broken code, all of it was written for CUDA. Today, millions of developers build on it on top of nearly 20 years of tools, tricks, and optimizations. Here's the way to see it. The world's AI software speaks a language that only NVIDIA's chips understand. And that changes what "just go to another store" actually means. A rival's chip isn't a substitute, it's a construction site. To use it, a lab would have to rewrite its entire pipeline, retrain its engineers, and re-verify that everything still works. In the middle of a race measured in months, falling a year behind to maybe save money isn't a bargain, it's surrender. So now you can put the two pieces together. The chips are physically scarce, and the substitutes can't run the world's AI software. Without a rewrite, nobody can afford mid-race. Leaving NVIDIA's line costs more than staying in it. That's why the line never moves. But don't mistake the companies in that line for prisoners. They are the richest, most capable organizations in history, and for a decade they've been digging tunnels. The giants are not stupid, and nobody accepts dependency like this without a fight. Google has been designing its own AI chips, TP-US, for a decade. Amazon builds Trainium, Meta builds MTIA, Microsoft builds Maya. Meta even signed a massive deal with AMD, NVIDIA's oldest rival. These are the richest companies in history, with the best chip designers money can buy working on Escape for years. So here's the twist you wouldn't expect. Those same companies keep placing record-breaking NVIDIA orders. Meta committed to millions of next-generation NVIDIA chips while building its own. Google buys NVIDIA for its cloud while selling TPUs. Why would you keep paying the company you're trying to escape? 3 reasons. First, custom chips are specialists, brilliant at the predictable, repetitive work of running finished models. But the frontier, training the next model, trying wild new ideas, keeps demanding the flexibility of the general-purpose machine. Second, the clouds have no choice. Their customers' code is written in NVIDIA's language, so a cloud without NVIDIA chips is a hotel without electricity. And third, every escape route runs through the same TSMC packaging lines we just saw. The tunnels don't bypass the neck, they lead back into it. Escape is real, but it works at the edges. The center holds. Which leaves the strangest question of all. If these companies resent this dependency so much, why does every single one of them keep ordering more? Not reluctantly, urgently. That last piece is what locks the whole system shut. Imagine you're running one of the biggest AI companies on Earth. You hate depending on NVIDIA. You'd love to stop buying their chips. So why don't you? Because in this industry, standing still isn't standing still, it's falling behind. Less compute, worse models, fewer users, less revenue. Top researchers leave. Now you can afford even less compute. 1 cycle behind becomes 2, then 3. That's the spiral every one of these companies can see, and it's why nobody dares to pause. Now, look at the other side of the ledger. Every check written out of that fear goes to NVIDIA, funding the next generation of chips, which now arrive on a relentless 1-year drumbeat. Each generation faster, each one making every alternative look a year further behind. Even your place in line is leverage. Give it up, and 100 buyers are waiting to take it, and you don't get it back. Fear drives orders. Orders fund the next chip. The next chip widens the gap, and the gap feeds the fear. Nobody designed this. Every company in it is acting rationally. The glass just keeps getting thicker. Nobody's trapped by NVIDIA. They're trapped by the race itself. Which brings us all the way back to the question we started with. If everyone is sealed inside the same glass, who's actually winning? Let's redraw the map. This is how the AI race is usually presented. A racetrack. OpenAI, Google, Meta, Anthropic, xAI. 5 companies racing toward the future. But rotate that picture 90 degrees. And something strange happens. It was never a racetrack. It was an hourglass. Unlimited money at the top. The future at the bottom. One narrow neck in between. And once you see that shape, you start seeing it everywhere. Railroads, oil, personal computers, artificial intelligence, different centuries, different technologies. The same pattern. Every revolution creates thousands of competitors, but almost every revolution creates one bottleneck. Eventually, every bottleneck disappears. Competition catches up. Governments intervene. Technology changes. It always ends. But while it lasts, the company standing at that narrow point doesn't just make the most money, it quietly decides how fast the future arrives. The races change history. The bottleneck decides when history gets there, and once you stop watching the races and start watching the bottlenecks, you're seeing the big picture.